Okay. Okay, so over here we have these three substances. Then we have HCl, HBr, Hi. So the things that differentiate them in terms of the boiling point, it is due to the strength of instantaneous dipole-induced dipole forces. Okay, so let us recall back what are the factors affecting the instant boiling point. Okay, yeah, usually we look at the boiling point first. So first thing first, we look at them. Are they having hydrogen bonding, right? Okay, so HCl, HBr, Hi, they do not have the, they cannot form hydrogen bonding. Okay, they cannot form hydrogen bonding. So only they move to the second factor, which is the number of electron. Okay, which is the number of electron. Then we can see the difference. ClBri, there is a difference in terms of number of electron, right? And Hi iodine, the I, it has the you can say greater number of electron among all these, right? So when we talk about here 2 marks, right? So the first mark I will recommend you to talk about you mentioned about the factors. So you can write Hi has greater number of electron. Okay, Hi has greater number of electron. You can state Hi has the greatest number of electron among HCl, HBr, Hi also can. Okay, so this one you will give awarded 1 mark over here. Then another mark, right? You need to mention about the strength. Okay, the strength of the instantaneous dipole-induced dipole forces. So hence, strength on dipole-induced dipole forces. Forces form between Hi molecules increases. Okay. Yeah. So over here, you will be awarded another marks. Okay, about the strength. You need to mention about the strength. If you want to write intermolecular forces, if possible, I don't recommend you to write the intermolecular forces, as intermolecular forces, it includes the permanent dipole. Okay, yeah, it includes about the permanent dipole. So if possible, write specific the name of the attractive forces, okay, which is the instantaneous dipole-induced dipole forces. And you better write the forces formed between what, okay? If you didn't mention about between the hydrogen iodide molecule, right? It seems like a little bit irrelevant, okay, in explaining. Okay, so if possible, write your sentence, be more specific, be more accurate. Okay, it helps you a lot. Okay, it will definitely help you a lot. Yeah, so this is the A Roman 1 Okay, now let us move to the next part. Hydrogen bonds form between HF molecules. So the first mark over here, right? They ask you to predict the boiling point of the HF. Okay, this kind of question, right? I would say predicting question. Okay, they come up quite frequently. Yeah, in these two, I think in these 2 to 3 years. Okay, if you have done some past question, I believe you will notice it. Okay, for example, I remember one time is they ask you to sketch the Boltzmann distribution curve. Okay, regarding the kinetic energy and the temperature one. Okay, yeah. So same thing over here. You need to sketch something lah. Okay. Then usually, okay, over here this question, right? As long as you draw a bar that is greater than the HI. Okay, the bar that is greater than the HI, then no matter how high is it lah, then you will be given awarded 1 marks over here. Okay, must be greater than here, this line. Okay, greater than the HI, the boiling point. Okay, as HF molecule, they can form hydrogen bonding. Okay, so 1 mark here. Then next, explain your answer. Okay, so the answer here, you need to explain why the HF bonds, the HF molecule, right? They why they have higher boiling point. So basically, right, you need to just do a very simple comparison. It's like you compare between hydrogen bond, okay, and the instantaneous dipole-induced dipole forces formed between HI molecule. Okay, here you definitely need to do comparison. Okay, let me show you some example. If today here you just simply write down like this, explain your answer. If you just write HF molecules can form hydrogen bonds. Okay, HF molecule can form hydrogen bond. So if you just write a phrase like this, no marks. Okay, why? As the question already told you that hydrogen bond can be formed between the HF molecule. So yes, I know this is kind of the answer, right? When you want to explain something, but over here, they already tell you that hydrogen bond can form between HI molecule. So if you write down something like this, it seems like you are copying the statement from the question. So you are not answering the question. Okay, yeah. So if you write something like this, no marks. Okay, then how are we going to write it? Okay, if you write something like this, no marks. Okay, then what are we going to write? Okay, you need to show comparison. So you just mention about the hydrogen bond formed between HF molecules, okay, is or are stronger than the instantaneous dipole-induced dipole forces form. You can write form between HCl, HBr, and HI molecule. Okay, so the very important words is you need to compare. So you need to mention about stronger. Okay, the hydrogen bond, they are stronger than what? Okay, which kind of the attractive forces? You need to mention about it. Okay, yeah. Okay, so here 2 marks. One is you draw the bar chart correctly. Another one is explaining correctly. Okay, then B. Okay, B is define questions. So over here, define the term standard enthalpy change of formation. So yeah, you need to define it. So formation, what is formation? Still remember, 1 mole of substance is formed from its element. Okay, yeah. So 1 mole, it must be 1 mole. Whatever the compound is, it must be 1 mole of the compound is formed. Okay, so you need to remember that what is the definitions of the standard change, the enthalpy change of formation. So it is the energy change or enthalpy change, up to you. Usually I will write down enthalpy change when one mole of a compound. Okay, enthalpy change when 1 mole of a compound is formed. Okay, so from here we can know that the compound is the product, right? So it's forming something. So it is product from its element. Okay, from its element. Then don't forget that they request you to write down the standard, right? So this standard basically means what? Means the standard condition. So if you do not want to write down the clear condition, means 25 degrees Celsius, 25 degrees Celsius, 1 atm, something like that, right? Then you can just talk about from its element in their standard state under standard condition. Okay, under standard condition. So from here, we know that the standard condition, it is 25 degrees Celsius, 1 atm, usually, okay, usually. Yeah, so 1 mark is mentioned, 1 mark is over here, 1 mole of a compound is formed. Okay, as long as you mention about 1 mole, then 1 mark, then from where? From its element in their standard state. Okay, in the mark scheme, they don't really give you about the marks for the standard condition, but personally, I will advise you to write it down. Okay, yeah. So you just add on the standard condition behind it. So 1 mark is for 1 mole of a compound is formed, another mark is for the elements. Okay, it must be the elements in their standard state. Okay, the standard state is very important. For example, water. Water, what is their what is its standard state? It is liquid. Okay, as we know that water usually it will exist right at room conditions. It will be at the water state. Okay, it's impossible for it exist at solid, right? So if you compare liquid and gas, liquid is a more stable state. Okay, and that would be its standard state. Usually we will look in this way. Okay, yeah, usually their standard state is a more stable state for that particular substance or chemical substance. Okay, yeah. Then the next question, it will be regarding about equilibrium. Okay, so when it comes to equilibrium, okay, first thing first here, they ask about Kp. Okay, please be careful. They ask about Kp, not Kc, not the concentration. Okay, it's about Kp. So what are we going to write down in the expression? It is partial pressure, not concentration. Okay, don't confuse between Kp and Kc. So what are we going to write down is the partial pressure product over reactant, right? So partial pressure for the hydrogen iodide. Okay, 2 here, 2 mole. So whole thing square. Okay, divided by the partial pressure of the hydrogen gas, then multiply with the partial pressure for the iodine gas. Okay, then you write in this way in the correct orientation, then 1 mark. Okay, make sure you have the square at the partial pressure for the hydrogen iodide. Okay, then the Roman 2. Equilibrium partial pressure of the gases at 200 degrees Celsius are as follows. Okay, 200. Then calculate the Kp for this reaction. Okay, actually this question is quite straightforward, as you just need to substitute all the value here into the expression above, right? So what you need to write down is just Kp equal to 4,800 square divided by 895. Okay, then here, if you are doing some calculation in chemistry, my advice is always minimum 3 significance figures, minimum 3. At most goes to 4 enough. Okay, usually the maximum they accept it will be 4. So 3 to 4 significance figure. So you can write down here the answer. It is 28.8. Okay, or 28.76. Okay, if you look at the mark scheme, you will notice that actually they accept 2 significant figures. Okay, yeah, sometimes they accept, sometimes they don't, but we do not know whether when they accept, when they don't. So my advice is always minimum 3. Okay, same things goes to your paper 3 calculation. Okay, calculation are not measurement. Measurement, you need to back to the sensitivity of the apparatus. Okay, I mean calculation means you calculate something using your calculator. Then you need to write down minimum 3 significance figure. Okay, yeah. Cool. Okay, if today they ask you about unit for these Kp expressions, okay, then what do you think? Is there any unit for this Kp? Pascal, 1/Pascal, or no unit? Okay, it should be no unit, as all the unit they can be cancelled out clearly. Totally can be cancelled out. 408,000 Pascal, but you square it, right? So at the what we call it, numerator part, okay, for the fraction, we will get Pascal square, then over it is the denominator, right? So Pascal square at the bottom as well. Then we can cancel out. Okay, we can cancel out. So if they ask about unit, you can just write no unit. Or another term is we call it dimensionless. Okay. okay, dimensionless means no unit. Okay, then Roman 3, okay, state how the value of the Kp would change if the reaction were carried out at 100 degrees Celsius rather than at 200 degrees Celsius. Okay, if your English, okay, is not that good, means if you come up to this question, right, you do not know what they want you to compare, right? Then my advice is you always look for the always look at the question, what is the temperature they provided to you? Okay, then if we go through here, right? Okay, just now I think they mentioned about 200. Okay, here 200. Okay, means initially the condition is the temperature is 200. Then right now they want the reaction carried out in 100. So from 200 drops to 100 means temperature decrease, right? Okay, temperature decrease. Okay, since temperature decrease, then we look at what is the enthalpy change. Okay, the enthalpy change here it is provided to you, right? Delta H. Okay, here it is endothermic. Okay, positive 26.5. Okay, then we follow this one. Okay, okay, we follow this one. So what happened here? Your reactions, the nature is endothermic, temperature decrease. So the system will tend to resist the change. So the change is temperature drop. So they want to resist the temperature drop. So what is the system going to do? They will favor the exothermic reaction as they want to release the heat, okay, to resist the temperature change. So they will favor exothermic. So exothermic is the reverse reaction, right? Okay, so equilibrium, it will shift to the left. Okay, yeah, equilibrium, it will shift to the left. So the first mark you mentioned about the equilibrium of this system or reactions. System, it will shift to the left. Okay, or you can write the equilibrium of reactions or system favor the formation of reactants. Also can, okay, as long as it shows the same meaning. Okay, then here you will get 1 mark. Then explain, okay, explain your answer. Why? As it is about the forward reaction is endothermic. Okay, yeah, you can say as the forward sorry, endothermic, not exo. Okay, then here you also need to consider the value of the Kp. Yeah, so Kp Kp decreases. Okay, Kp decreases. Okay, 1 mark is you explain about the equilibrium shifting to the left. Okay, then another mark is you write down the forward reaction is endothermic and you state how is the Kp change. Okay, you can write Kp decreases, the value of Kp drops, okay, decline, all these can. Okay, then next. Okay, Hi reacts with oxygen to form iodine and water. Okay, I remember this reaction we don't really learn in our syllabus, but as long as they provide enough information to us, then you should be able to construct it. Okay, yeah. Then Hi plus oxygen gas O2 to form iodine I2 plus water H2O. Okay, over here don't write state symbol. Okay, don't. If the questions didn't ask for it, then you don't write it. Okay, if you want to write it, make sure it is correct and every species has state symbol. Okay, don't just reactants have the state symbol, then the product doesn't have. Okay, don't do something like this. If you do not want to write, then don't write. If you want to write, then write for every species in the equation. Okay, yeah, then you try to balance it. We have O2 at left hand side, then we only have O at the right hand side, so 2 mole here. For H, then 2 by 2 multiply 2 for 4 Hi, then for I 2 by 2. Yeah, you balance it correctly. Every species you write down is in the correct formula, then you will get the marks. Okay, then the next, explain with the reference to oxidation number why this reaction is a redox reaction. Okay, this is I would say the very easy marks for you to score. When they ask about when they ask you why this is redox reaction and they ask you to explain with reference to the oxidation number, then you just state about the oxidation number, how it changed, okay, from what to what. Okay, yeah. Then from here we can see that the element, right? What happened here is element O2 it changed to sorry, let me rephrase it. The element at the left hand side is oxygen gas. Then the element at the product side is the iodine. So no matter what is the species, as long as it is element, the oxidation number is 0. Right, 0. Hi, the I is -1. Right, the oxidation number. Oxygen is -2 in the water. So from here we can see it very clearly. The I undergo oxidation and the O undergo reduction, right? So here what you need to write it down is the oxidation number of I, okay, increases, okay, increases from -1 to 0. Okay, state the change. Okay, state the change. Don't just write increases. From what to what, write it down. Okay, yeah. Then the oxygen is the oxidation number of O decreases from 0 to -2. Okay, from 0 to -2. So very simple 2 marks here. As long as you can state how is the oxidation change of I and O, then you already score 2 marks here. Okay, yeah. Okay, then E. Okay, this is actually they test the concept of your ideal gas law. Okay, we know that the ideal gas law is PV equal to nRT, right? PV equal to nRT. Okay, if you look at the questions, okay, let us go through together. State the change in pressure. So pressure is one of the variable that is going to change when 2 mole of the iodine gas react with 1 mole of the hydrogen N2H4 in a sealed container. Okay, underline sealed container. Sealed container means constant volume. Okay, constant volume, then constant temperature. Okay, so means volume fixed, temperature fixed. So from here, what can you see? R is definitely constant, right? R is the gas constant, so it is definitely not going to change. So what happened here is we can see the relationship between pressure and the number of mole of gases. Okay, it must be gases. That's why you can see all the species here, they are in gases. So number of mole of the gases, we say the reactions mixture. Okay, initially is 2 mole reacted with 1 mole, right? So 2 plus 1 total 3 mole of the reactants. Then what happens to the product? 4 plus 1. So we have 5 mole at the product, 3 mole at the reactant. So 3 to 5. It shows increase, right? Okay, so when the number of mole of the gases increases, what happens to the pressure? Increases as well. Okay, yeah, so state the change in pressure. Pressure increase. Okay, the pressure increase. As long as you state pressure increase over here, you will get 1 mark. Okay, the pressure increases, 1 mark. Then another mark is you need to explain it. Okay, so the pressure increase as the number of mole of gases. Okay, you need to mention about gases. Okay, number of mole of gases. You can write molecule or particles. Okay, increases. Okay, throughout the reaction. Okay, then if you want over here, I remember the mark scheme shows that you can no need state how is the change, okay? But they also, that is optional, okay? Not sure, no need. It is not saying no need, but it is just optional. Okay, if you want to show how much it is, how much the number of mole increase, right? For example, here 3 to 5. So you can write in this way. Okay, I show you another way to write it. You can write down the number of mole of gases molecules increases. Okay, increases in, you learn this kind of the way you write it, okay? Increase in ratio. Okay, we use ratio. 3 reactants to 5 product. Okay, yeah. So if you write in this way, it shows more clearly. Okay, it shows more clearly in your understanding. Okay, yeah. So if you over here, you can write generally. as the mark scheme accept it, means you can just write down the number of mole of gaseous molecule increases throughout the reactions. No problem. You will also score the second mark. But if you want to write it down more accurate, then you can learn this type of the, we say, writing, okay, in ratio, how much reactants to how much product. But if you want to write down the more accurate one, make sure you write down the number is correct. Okay, you need to follow back the equation. Okay, if you write wrong in terms of ratio, then I'm not sure whether they will deduct lah. But if I am the marker, I will deduct the mark, as you don't really answering the question. Okay. Okay, then F. F, this one is the dot and cross diagram. I believe that you should know how to draw the dot and cross diagram. Okay. Dot and cross diagram, personally, last time did I ask? I remember is you should draw the circle, okay? I mean, you need to show the outermost shells, okay, showing the line, the circle, okay, the circle or the orbiter, okay, the orbiter. Okay, so Pi3, let us recall it back. So phosphorus is like nitrogen, right? It has 5 valence electrons, and iodine, it has 7 valence electron. Okay, phosphorus has 5 valence electron. Iodine has 7 valence electron. So iodine, it wants to achieve stable octet electronic configuration. So it needs to receive 1 electron. Okay, so P will share its electron with I. So over here we have 3I, right? So means 3 of the valence electron of phosphorus atoms, they are going to share with I. So we will have P single bond, single bond, single bond. So we will have I. Then 5 valence electrons already use up 3. So we have another 2 as lone pair. Okay. So this is how the geometry of the molecule looks like. Okay. Okay. Did they ask? Oh, they didn't ask. Then let me ask you, what is the geometry of Pi3? What is the name? Still remember? Trigonal. Yes, it is trigonal pyramidal. It is similar with the NH3, right? Yes, trigonal pyramidal. Okay. Yeah, make sure you familiarize with all the name of the geometry. Okay. So when it comes to drawing the dot and cross diagram, we will write down P. Okay, P as the central atom. So usually we will write it at the as the starting. Okay, so P, then you draw the circle. Okay, then I use another color. Okay, then please remember shows overlapping. Okay, overlapping. Right. Okay, another I, then another I. Okay, then shows the electron. Okay, when it comes to electron, please using 2 different symbols. Okay, as you have P and I. So let's say I use cross for the iodine atom. Then each iodine, it has 3 lone pair. 1 electron is shared with the phosphorus, right? So 1 here. Then don't forget your lone pair surrounding the I. Okay, then dot. Let's say dot over here is for the phosphorus. Okay, then. Okay, how is the mark showing here is as long as you show 3 single bonding pair. Okay, 3 single bonding pair here. 1, 2, 3. Then you will be awarded 1 mark. Okay, yeah. Then another mark is the other electron. Okay, make sure you draw all the lone pair surrounding in at the I atom, also the P atom. Okay, yeah. So 2 marks here, dot and cross diagram. Okay, then name the type of the reaction in step 2. Okay, let's look at step 2. Step 2 is this reaction. What is the type of the reaction? Pi3 plus H2O become H3PO3 plus 3Hi. Water react with the Pi3. What happens to the water? It undergoes, we say, splitting, right? It breaks down the water. Do you notice it? Okay, it is something like this. You can see OH. OH basically, it is here. And another H go to the HI, right? Okay, so 3 mole of the H2O, 3O goes to the H3PO3, 3O also 3O and 3H goes to the H3PO3. Then another 3 goes to the HI. So basically what happened here is the water is breaking down. Okay, the water molecule is breaking down. So this type of the reaction, we always call it hydrolysis. Okay, yeah. Make sure you know this type of the reaction. This is, I think, group. Okay, not group. Chapter PI3. PI3. Have we learned PI3? I'm not sure, but similar reaction, for example, SiCl4. Okay, react with H2O. Yeah, it is hydrolysis as well. Okay, so all these you can notice. I remember is the period 3, chapter 9. Okay, yeah, you can find the similar reaction. Okay, so this we call it hydrolysis. Make sure you know about it. Okay, next. Okay, next is strong roasted rolling acid. Okay, in your syllabus, you only learn one definition of acid and base, which is Bronsted rolling. Okay, you didn't learn about Arrhenius, you didn't learn about Lewis. No, only Bronsted rolling. So for you, I would advise since you only one type of the definitions, then you just memorize it. Okay, you no need to. Okay, I mean you don't confuse okay, between the different definition. Bronsted rolling, the definition, we always look at the proton. Okay, we look at the proton. So acid is proton donor. Okay, 2 marks here. 1 marks, it goes to the proton donor. So proton donor. So you can write down it is the proton donor that, okay, Then the next mark is you need to explain about strong. Okay, you need to explain about strong. So strong acid means what? Means it is able to fully ionize, or we say dissociate. Okay, depends on you which term you want to use. Ionize in the water. Okay, 2 marks here is 1 mark goes to the proton donor and another mark goes to the fully ionized in the water. Okay, then give the formula the conjugate base of H3PO3. Okay, you need to know how are we going to identify, for example, conjugate base or conjugate acid. Okay, conjugate base is the acid that donated or already released the H plus. Okay, so means that you can, if you cannot identify it directly, why not you try write down the equation. H3PO3, right? H3PO3, it is acid, then it will give away, or we say donates the H plus. Then what is the remaining structure? So 1H is already left, so we have another 2, right? So H2PO3. Then how about the charge? 1 positive, we want to make sure it, we want to make it become neutral, so negative here. So this is acid. Then this is, we call it conjugate base. Okay, let's say until today you still do not know what is conjugate base, then this is how we identify it. Okay, so it will be H2PO3 negative. Okay, then next G. So actually, the first question is quite long, as it comes up until the G. Yeah, and the total marks for the first question is 26. It's already covers half of your, almost half lah. Okay, half is 30, right? 26 is almost 30 already. Half of your paper 1, paper 2 marks. Okay, yeah. Okay, then over here, hydrogen iodide gas react with the propene. Okay, propene is double bond. Okay, they already give you the formula. Yeah, they are very kind. Give you the formula to form a mixture, 1 iodine propane and 2 iodine propane. They even give you the name of the product. Yeah, then they just ask you to identify, means you select one. Okay, 50-50 chance. So which one is the major product? Then you explain your answer. Okay, here. What you need to recall here is, first thing is Markovnikov rule. Okay, Markovnikov rule. Markovnikov rule states that the hydrogen atoms will go to the carbons that attach to the most hydrogen atom. Okay, means that here we have 2 carbon, right? 2 carbon, these 2. Okay, we only look at the double bond carbon. Okay, we only look at the double bond carbon. So one double bond is only have 1 H, another one is have 2 H. Right, so according to the Markovnikov rule, H will go to this place, right? Okay, H will bonded to this carbon, means that the I, it will bonded to the carbon in the middle. So which one is your major product? 2 iodopropane. Okay, 2 iodopropane is the major product. Okay. as long as you write this statement, you get 1 mark already, as you identify it correctly. Okay, then, okay, when it comes to explanation, okay, this one, yeah, I didn't teach you guys the organic, right? Okay, okay, and then let me tell you, Markov-Nikov rules is only for prediction. Okay, Markov-Nikov rule is only for prediction. When it comes to explanations, never use Markov-Nikov rule. Okay, I mention it one more time. When it comes to explanations for why it is major product or minor product, never use Markov-Nikov rule to explain. Okay, when it comes to explanation, we always explain from the perspective of carbocation. Okay, carbocation. Yeah, this is how Markov-Nikov rule is applied. Okay, actually the concept behind it is due to the stability of carbocation. Yeah, so to form 2-iodopropane, okay, to form 2-iodopropane, okay, I think I shift to here to explain it better. Okay, yeah. So for 2-iodopropane, right? 2-iodopropane. No, we start from the propane. Okay, so if you look at the mechanism, CH double bond CH2, then we have HI, right? Okay, we have HI. Here is delta negative, here is delta positive. So the double bonds will come to attack the H plus, sorry, not the H plus, is H. H for the ion, hydrogen iodide, then the bonding break goes to the I. Okay, then we will get something like this. Okay, we will get something like, we call it intermediate. So CH3, then CH3. Okay, the H is added to this carbon, as we are going to explain why 2-iodopropane is major product. So H is added to the carbon with the most H. Okay, so what happened now is this carbon, the middle carbon, it is positively charged. So if you look carefully, this carbon, right, it is secondary carbon. Sorry, secondary carbocation, not carbon. Carbocation ion. Okay, then if you draw it up for the, we say it for the minor product. Okay, minor product, it will form something like this: CH3, CH2, CH2 positive. Then this carbocation ion is primary carbocation ion. Okay, so now you can see clearly, right? One is secondary, one is primary. So from here, we need to talk about stability of the carbocation ion. Yeah, and the top one is about major. This one is major product. Okay. Okay, this is major product. The bottom one is the minor product. Okay, yeah. So I draw it up is I hope that you can see it clearly why there is primary or why there is secondary carbocation. Then we let us go back to the paper. Okay, so when it comes to explaining, remember we explain always using the carbocation, stability of carbocation. So why 2-iodopropane is propane? Sorry, here it should be O. PRO. Okay, is the major product as it is formed from a more stable secondary carbocation. Okay, yeah. Then you need to further explain in terms of why secondary carbocation is more stable, because it has greater positive inductive effect. Okay, all these already I have shown in the notes already. Okay, positive inductive effect of 2 alkyl group. Okay, 2 marks here. Okay, positive inductive effect, it is about we say alkyl group, right? Alkyl group actually they are rich in electron, so they can so-called donate. Yeah, the idea is like they donate, but they don't really donate. Is they let the electron closer to the C positive carbocation. Then this positive, right? It can be stabilized. Okay, it can be stabilized. So when the carbocation is more stabilized, then the carbocation they are not reactive. Yeah, they are not reactive. Means they can stay at that state, intermediate state, more likely. Okay, so this is the reason why the tertiary, secondary, they are the major product, because they can stay at that state, then allow the iodide ion comes and attack them. Okay, yeah, comes and attack them. Then they can form more this kind of the product. Okay, yeah. So please make sure you know how to explain when it comes to the Markovnikov rule, okay, or something that involves the carbocation. I remember the SN1 and SN2, right? Nucleophilic substitution for the halogenoalkane. There is this. They can also ask this type of the question, okay, on the nucleophilic substitution, as SN2 is involved the formation of carbocation. Yeah, SN2. When SN2 is one step. Oh, sorry, no. SN1 is involved the formation of carbocation. Okay, yeah, SN1 involves the formation of carbocation. SN2 is, it doesn't involve the formation of cation, but it has the complex form of the carbon with the negatively charged. Okay, that one is SN2. 2 is one step, yeah. Okay, so 2 marks here. Then the bottom is the mechanism, right? Okay. So draw the major product identified in the G Roman 1. Okay. If I say lah, okay, let's say if you are given this type of the question, it is actually good for you as mechanism. Actually, it is a very easy way for you to score. Okay, yeah, means there is no tricky part when it comes to mechanism. They always follow the same rules. Okay, and in this question, right, they even draw, I would say, many things for you already. They include the reactants, means the propene, the hydrogen iodide. They even draw the partial charge for you. Okay, yeah, this is something, right, usually question doesn't provide, but this year they provide. Okay, I believe that they notice a lot of you always forget it. Okay, so when it comes to mechanism, please remember always write down the partial charge. Okay, then for this reaction, it is electrophilic addition. So we added the reagents across the C double bond C. Then our nucleophile is our double bond. Okay, the alkene. So the bond, the arrow you draw, right, you must starting from the double bond, attack the H. Okay, then the HI bond is broken. Okay, so these two electrons move to the bonding pair, move to the I. So over here, right, you should have something like this as your intermediate. Okay, they ask you to write down or to show the structure of the major product, right? So H single bond C, single bond C, and here we have CH3. Yeah, then you can show the positive charge here. You must show the positive charge, huh? Okay, here the C positives means that this is the carbocation. So obviously from here you can see there are two R group, CH3, CH3, right? So two R group, secondary carbocation. Then only you show the I with the lone pair, I with the lone pair and the negatively charged. Then attack the carbon. Okay, attacking the carbon of the carbocation. Then at the end, right, you just shows the complete structure. Yeah, something like that. So then you will score the 3 marks. Okay, yeah. For mechanism, okay, because this, right, this you only have one product. I mean, you do not, this reaction you are not going to have byproduct. Okay, for example, not substitution, right? This is addition. So addition is two combined to become one. So let's say if today they ask about substitution reaction, then my advice is at the product side, you always shows the format, you always shows the side product, means you write down the formula. Even your side product is H2O, you write it down, or HI, HBr, HCl, write it down. Okay, sometimes the marks, they sometimes you need to show byproduct, then only you can score the last mark. Okay, yeah, so we do not know when you need to write down the side product. So always when it comes to mechanism, write down everything. Okay, major product and also the byproduct. Okay, then only we comes to the question 2. Okay, question 2. It is a bit hard. Yeah, especially when it comes to the donkey, I would say. Okay, which is the things that you are not familiar. Okay, number 2A, Roman 1, complete the row in the table, label bonding present in element. Okay, here is, okay, the answer is, this is metal, this is metal, this is covalent, covalent, covalent. I believe none of you write, I write, okay, as they ask element. Ionic bond never present in element. Okay, ionic bond only present between cation and anion. Yeah. Okay, so I hope that none of you write I. Okay. Yeah. 11, 12, 13, they are metals. 14, 15, 16, 17, they are covalent compound. Okay. Okay, then Roman 2. Explain the difference between first ionization energy with the atomic number 11 and 17. Okay, 11 and 17. So you can see here, it is 494 and 1260. They are not asking about the trend. Okay, let me emphasize here, they are not asking about the trend. They are just asking about the comparison between 11 and 17. That's all. So you no need to explain about the trend over here. Okay, you don't write something like this. The first ionization increases across the elements 11 to 17. If you write something like this, basically you are not answering the question. Okay, they just want you to compare between 11 and 17. So compare very easy, right? Why 494 11 is low, then the element 17, it has very high first ionization energy. So explain the difference. Okay, from 11 to 17, okay, they are at the same period. Same period means same number of shell. Okay, when they have the same number of shell means they are going to have the same shielding effect or screening effect. Okay, yeah. When it comes to the first ionization energy, in your minds, okay, you should have these two factors. One is the nuclear charge, or you can use proton number to explain. Okay, nuclear charge or proton number. This is the first factor we can use. Second factor, it is about the shielding effect or screening effect. Both can. Okay, so yeah, these two factors you need to apply here. Okay, yeah. So 2 marks, although here 2 marks, but basically the masking shows 3 points. Okay, with all these 3 points, you are given 2 marks. 2 points, 1 mark. If you only have 1 point, no mark. Okay. So, okay, comparing between 11 and 17, right? So you can write down the element. Okay, the mark scheme, they show the answer in this way lah. Okay, they say the element 11. Okay, yeah, the element 11 has a greater nuclear charge. Okay, yeah, maybe they accept in this way. I believe since they shows it in the mark scheme, right? So I believe that the accept the short form, so-called short form, 11, element 11 is the short form for element with atomic number 11. Okay, but in exam, right, you do not know how to describe it, then I would advise you refer back to the question. Okay, you look over here, they use that the first ionization energy of the elements with atomic number 11 and 17. So why not you just follow back? So let's say in exam, you are given something like this, okay, an unknown. Okay, so you can write down the element with atomic number 11 has a greater nuclear charge. Okay. Then I would say it would be more accurate. Yeah, the answer. So this will be the first point. Sorry. The element with atomic number. Yeah. Sorry, mistake. Thank you. 17. The element 17 has a greater nuclear charge. Yes. Okay, so this is the first factor. Okay, then second factor. Okay, second factor, I believe some of you might ignore it. However, over here, if you found out that both elements, they come from the same period, I will advise you, even though they have the same effect, I advise you to write it down. Okay, so both elements have the same shielding effect. Okay, this kind of the questions, they comes up quite a number of times already, and every time, right, they have this answer. Okay, means both elements have the same shielding effect, means even though they are the same, you are required to write it down. Okay, you are required to write down. So second points are given to this statement. Okay, same shielding effect. Then the third point is goes to, okay, first ionization energy, basically referring to what? The nuclear attraction, right? Okay, yeah. So you can write down, hence the nuclear attractions of the elements with atomic number 17 becomes greater or becomes stronger. Yeah, so this will go to the third point. So 3 points, 2 marks, 2 points, 1 mark, only 1 point, no marks. Okay, then Romans 3, explain the difference between first ionization energy of the element with atomic number 15 and 16. Okay, 15 and 16, let us look at the difference. Okay, 15 and 16, right? You will notice that for the first ionization energy of the element 16, it shows a little bit lower. Compared to the 15. Means this is the anomalous, right? Okay, then let us recall back. We learned about 2 anomalous. One is between 12 and 13. Another anomalous is on 15, 16. Okay, to be more specific, it is between magnesium, aluminum, and this one, third period, like so phosphorus, to phosphorus and sulfur. Yeah, phosphorus and sulfur. Okay, yeah. So, for the phosphorus, okay, I write down. Phosphorus here is actually 3s, 3p. It is something like this, right? 3s and 3p. So there are only 3 unpaired electron. Okay, single unpaired electron. 3 single unpaired electron in 3p orbital. Then in s, there is pair electron. There is pair electron in the sulfur atom. So means there is the electron pair repulsion, right? So you need to mention about this repulsion over here. Okay, so there is electron pair repulsion. In 3p orbital, 3p orbital of elements with atomic number 16. Okay. Okay, as long as you mention about electron pair repulsion in which orbitals. Okay, over here, I noticed mark scheme they highlight the 3p orbital, means they want you to write it down. So yeah, better you write it down. Then it is the element with atomic number 16. Yeah, correct. Okay, so 1, 2. Okay, yeah. In mark scheme, I remember as long as you mention electron pair repulsion, you get 1 mark already. Another mark they give on the location of the orbital, means it is 3p orbital. Yeah. Then you already score 2 marks. However, my advice is you write it you should explain it more details. Okay, so my answer here is you need to mention how is the repulsion helps in the first ionization energy. Okay, so I will advise you write down this phrase: the electron pair repulsions assists, okay, assists in the process of removal of electron. Okay, removal of electron basically is ionization process. Okay, you can also write down assist in first ionization process or ionization process, no problem. Okay, then thus less energy is required. Okay, personally, I think this would be a more complete answer, yeah, for you as a student in answering the question. Okay, then we look at number 4. Okay, complete the row in the table, label maximum oxidation number. Okay, for this one, I believe that for the 11, 12, 13, you shouldn't have any problem. I think 14, you should have no problem as well. Okay, then most of you may have some identify the maximum oxidation number of the element 15, which is the phosphorus, and the sulfur. Okay, the 16. Okay, the maximums, then you need to be able to remember a few molecule. For example, PCl5. Okay, Cl you have 5, right? So -1 for each chlorine atom, the oxidation number. So phosphorus, it need to be +5. This is the maximum. Okay, so the maximum of the phosphorus or the elements 15, it is +5. Then for the 16 sulfur, it is +6. As we have the structure, something like this, SF6. Okay, F is the -1, the oxidation number. Then the sulfur, it will become +6. Okay, same thing for H2SO4. The oxidation number for the sulfur is +6. SO3, the sulfur also +6. Yeah, so all this you should be able to, we say, remember, then you need to be able to relate. Then only you can know what is the maximum oxidation number for the phosphorus or the sulfur. Okay, then yeah, we'll move to the next questions, Roman 5. Okay, for the Roman 5, right, explain the variation in n-ionic radius. Okay, for the elements with atomic number 14 to 17. Okay, n-ionic radius. Over here, they provide you some information. Yeah, for the here. Okay, so obviously it shows decreases, right? Decreasing trend. Okay, then why the n-ionic radius shows decreasing trend from element 14 to 17? Okay, then you need to explain about what? About the proton number and number of electron. Okay, number of electron here is very important. Okay, if you look carefully, right, for the elements 14, 15, 17, 14, 15, 16, 17. Okay, S 2.8.4 is silicon. Okay, so we have silicon 4 negative, phosphorus 3 negative, sulfur 2 negative, and Cl negative. All these anion, they have the same number of electron, which is 18. Okay, they have the same number of electron. Then what is the difference? Difference is the proton number. Okay, silicon has 14 proton, phosphorus 15, sulfur 16, silicon 17. Okay, so you can see they have the same number of electron, but they have different number of protons. So over here, you can see the nuclear charge is different, right? Okay, they have the same electron, but nuclear charge different. Yeah. So 2 marks here. Then what you need to write down is, okay, first thing first, you can say that all the anion here have the same number of electron. Okay. Okay, then comma, but increasing proton number. From elements 14 to 17. Okay, then we talk about the nuclear attraction, or the attraction between the nucleus and the valence electron. Okay, yeah, so hence the nuclear attractions increases. Okay, from elements 14 to 17. Okay, how is the 2 marks is given? Okay, if you mention, as long as you mention same number of electron and increasing proton number. Okay, you need to state both. Sorry, no, it is not given in this way. As long as you state same number of electron, 1 mark. Okay, another mark is you state increasing proton number and the nuclear attractions increases. Then you will get the second mark. Okay, so from here I emphasize again, in the Roman 2 we can see same shielding effect is given marks. Over here in the same questions, same number of electron is also given marks. So in exam, if you encounter this kind of the questions, please write it down, even though they are the same. Okay, even though they are the same, write it down. Sometimes they give marks. Okay, B. Okay, yeah, this one actually it is quite surprised when I look at this question, as they come out this graph sketching. I never expect it's come out, you know. As I remember in the syllabus, they ask describing the trend. So yeah, in notes you are provided the graph. But I don't think you memorize it, right? Okay. Yeah. Okay. First thing first, across the period 3, what you need to know is 11, 12, 13. These 3 elements, right? They are metal. 14 is the giant covalent compound. Okay. 15, 16, 17, they are simple covalent. Okay, this is the first thing that you need to know. Okay, then when it comes to plotting, right, from 11, 12, 13, you need to show increasing trend. 1, 2, 3. Okay, increasing trend. As back to the metal bonding, metallic bonding getting stronger when the number of the localized electron per atom increases. So that's why the melting point increases. Okay, Si is 14 is Si. Si is silicon. So it exists in the giant covalent compound. Okay, it has the extended structure. So the bonding present in the silicon is the covalent bond, and it is extremely high melting point, even higher or greater than the metallic bond. Okay, yeah. Then comes to 15, 16, 17, right? You need to show this trend. 15 is somewhere middle. wait, the 11 one I shows it to bottom already. 11 I show it higher a little bit. 12, 13, then 14 it goes very high. Okay, when it comes to 15, let's say here I plot it here. Then 16, you need to show slightly higher the melting point. Then 17 is the lowest. Okay, then you join them together. 1, 2, 3. Yeah. Okay, then 2 marks. Okay, for this part, I forgot. How is the marks given already? If not mistaken, okay, if not mistaken, for the front part, okay, here, as long as you showing increasing trend, okay, as long as you show increasing trend, 1 mark. Okay, another mark should be given here, the covalent part. Another mark. Yeah, should be. Okay. Okay, let me explain here why the element 16 it is slightly higher, as it is sulfur. Sulfur, it will exist in S8 molecule form. Okay, P is P4. C17 is Cl, right? So it's just Cl2. So in terms of the number of electron per molecule, sulfur S8 molecule, it has the greatest number of electron among these three. That's why it has the highest melting point among these three. Okay, yeah. So you are required to know this part. Okay, they will usually they will ask you to explain the melting point or boiling point. Yeah, for this part. Okay, but this year they ask you to sketch the graph. Yeah, first time. Okay, then C. Okay, C here is another predict value. Okay, for the prediction, right? Okay, listen, for the predictions, personally, I will advise you to take the middle value. Okay, so means what? Means like, for example, 2.34 and 5.91, right? Okay, the middle, it should be somewhere around. Okay, you can just sum them up, 2.34 plus 5.91, then you divide it by 2. So you should get around 4.125, right? Then you can just write 4.1 or 4.12, 4.13, no problem. Okay, for example, 4.13. Okay, then this is it will definitely lie within the range. Okay, definitely. You don't write something like, okay, it is 2.34 at above, right? So I write 2.40. Okay, don't do this. Always select the value that close to the midpoint. Okay, as the question, the answer, right, the accept the range is between 2.5 to 5.0. Yeah, 5.0. Okay, if today you just 2.4 or even you write 5.1, they will give you wrong, Okay, so my advice when it comes to the predictions, always write the value that is close to the midpoint. Okay, means you take the above value at the next value, okay, the previous and the next value, right? You sum them up and divide it by 2. Okay, then the value, right, they will definitely lies between within the range. Okay, so here you can just 4.0, no problem. 4. Okay, it is in the range, no problem. Okay, then the boiling point, the value is 1500 to 2300. Yeah. Okay, the range for the boiling point they accept. Then for the cation radius, it is about 0.055 to 0.075, the range they accept. Okay, if you use the midpoint method, you sum them out, then divided by 2, then you will get around 1930 for the boiling point, which is within the range, right? Then for the cation radius, 0.05 plus 0.081, then divided by 2, you will get 0.0655. So let's say you round off 66. It is in the range as well. Okay, so if come up with the prediction, use the you find the mean, okay, the midpoint between them. 3 mark here, very easy 3 mark, then you get. Okay, yeah, then let us move to the not Roman, D-donkey. Okay, indium and aluminium, they are elements in group 13. So indium has very similar chemical properties to element. Okay, be careful with this phrase. Okay, this kind of phrase, they keep coming up in the questions. Okay, if you have done past year, you will notice it a lot of times. You will come across with this phrase. They will give you something that you never learn in your syllabus. For example, indium, right? You never learn it in your syllabus, but they give you a reference, okay, which is aluminium. You learn aluminium, right, in your syllabus. So whatever the aluminium reactions that you learn in the notes, okay, then now you just replace the aluminium with the indium. That's all. Yeah, that's all. Okay, so here they provide 3 reactions for you, or 3 properties. Yeah. Okay, then indium react vigorously with hydrochloric acid to form a colorless gas and a salt in a solution. So what is the formula of salt form? Okay, so over here you just replace the indium with aluminium. So aluminium react vigorously with hydrochloric acid to form a colorless gas and a salt in a solution. So aluminium with the HCl, metal plus acid, you will get salt plus hydrogen gas, right? So the colorless gas here is actually, it is hydrogen gas, okay, and a salt. So if it is aluminium, then the salt, it will be aluminium chloride. So today we use indium, so it will be the indium chloride, IN, okay, InCl3, just like this. Okay, yeah. Then point number 2, or second properties, indium oxide In2O3 is amphoteric. So same thing applies to the aluminum oxide, right? Okay, aluminum oxide is amphoteric as well. So construct an equation for the reaction of indium oxide with SS equals NaOH. Okay, this. Amphoteric, if today oxide behave as a base, I believe you have no problem in balancing the equation. But right now, indium oxide or aluminum oxide, you are going to show it behaving as acids. Then I believe some of you may not know how to so-called balancing the equation. Okay, yeah. So let us write down first. Indium oxide plus NaOH. Okay, to form something, right? To form something. Okay, from here, actually, in the notes, right? I think I only shows you this reaction. Actually, there are two different equations. This equation is for the complex form. Okay, complex form. So what does it mean by the complex? Okay, it's in this way. Okay, what you need to know is in the complex form or the complex ion here, the N ion is OH. Okay, the N ion is OH. Then you write down all the cation together, Na and also In. Okay, Na and also In. So Na, the oxidation number is +1, right? Means 1 positively charged. In is 3 positive. So 1 positive and 3 positive. The total charge here is 4 positive. Okay, the total charge is here 4 positive. So how many hydroxide we should have here in order to balance it to become neutral? We have 4 positive. OH is negative charge only, right? So we need to have 4 OH to balance it. Okay, this is the sort that you need to so-called remember. Na, In, then bracket OH4. OH4. Okay, then balance it. Okay, so when it comes to balancing, you will notice that In we have 2 here, right? So we need to balance 2 here. Okay, 2 here. Then oxygen 3 here have 4. O4. Okay, but hydrogen we have 4 as well. H2 4 is impossible to balance H and O together. That's why we balance another H2O here. Okay, H2O, we need to add on H2O here. It is because we want to balance the O and the H. As if we didn't add the H2O, the O and H, they never balance it. Okay, you can never balance it. Okay, then H2 4 here. Here you need to have 2. 2H, then 4H. Oxygen, we think 8. Your hydrogen, okay, 3 here. 6 plus 2, 8. 4, 2, 8. Okay, hydrogen balance. Indium balance, sodium balance, oxygen 4, 8. We have 8 oxygen here. So 3, 3, 2. So total 8. Yeah, this is how we balance it. Acid. Okay, yeah. Okay, the next it is about the diagram for the In2Br6. Okay, and they told you already this molecule or this compound, they have coordinate bonds. Okay, so for the coordinate bond, you need to show it. Okay, draw a diagram that clearly shows type of the bond. This one is dimer. Okay, the dimer that we learned in our syllabus, it is about Al2Cl6. Okay, the dimer. So when we draw it, so it will be single bond Br, single bond Br, single bond Br, then receiving lone pair from another Br. Here, Br, Br. Okay. So this is the structure for the In2Br6. Okay. 1 mark as long as you show the correct structure. 1 mark. Another mark is given to the dative bond or the coordinate bond. Okay, that will be the question 2. Okay, now let us quickly go through the number 3. Okay, name the T. Okay, so this one is alkene, right? Okay, alkene. So you should have ENE lah as your, we say, parent change. Then first thing first, when it comes to the nomenclature means naming the compound, I will advise you to circle the parent change, which is usually the longest one. So we have 4 carbon here, so it should be butene. Okay, that is the double bond. Let's say 1, 2, 3, 4, 4 carbon, right? So at the second carbon, okay, if we count it from the left hand side, so butene. Okay, then how many side change? Okay, we have 1 side change, 2 side change. So where is the positions? 2 and 3, right? So it will be 2, 3 dimethyl butene. Okay, 2, 3 dimethyl or dimethyl butene. Okay, 1 mark. Okay, B. Draw the skeletal formula. Okay, highlight skeletal formula. Okay, skeletal formula of a structural isomer of T. Okay, that shows Cistron Isomerism. Okay, it must be isomer that showing Cistron Isomerism, and your answer must be skeletal formula. Okay, this is very important. And they only ask for 1. Actually, over here, right, they can accept quite a lot number of answers as long as you draw it correctly. Okay, and they only ask for 1, right? So for me, you don't go to so-called make yourself suffer lah, as they already told you the molecular formula, right? C6. So let us make it straight change. Simple, right? Let us make it straight change. So 6 carbon. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and your double bond, right? As long as you don't show the double bond at the terminal carbon, then your alkene will definitely show Cistron isomerism. Then this is one of your answer. Okay, or you show like this, then double bond at the middle, also can. Okay, there are some other answer, but I don't think so we go for that lah. These 2 is more than enough actually. Okay, yeah. Okay, then C. Okay, C, we are going to show the pi bond. Okay, the pi bond that is present in the T. They already shows you all the sigma bond here, right? Then when you ask you to show pi bond. Okay, over here your pi bond you cannot show in like this. Here one goes up, goes down, goes up, goes down. If you show it in this way, wrong. Okay, why? You didn't show overlapping. Okay, you have to show overlapping. Okay, so over here you usually we draw it something like this. Okay, then you usually we will darken it. Okay, or you shade it. Okay, overlapping upside down. Okay, overlapping laterally. Then as long as you show the overlapping of the p orbitals, then you get 1 mark. Okay, then C Roman 2 state the hybridization. This one easy lah. Okay, double bond, so only one double bond, sp2. Okay. Okay, then D donkey. Okay, so some organic reactions coming out already. Okay, TUV. Okay, a reaction scheme starting from T is shown below. Reaction 2 occurs in the presence of catalyst. Okay, that is catalyst for the reaction 2. Knowledge for the mechanism of this reaction is not required. So, okay, mechanism is not required. Then give the reagent and condition for reaction 1. Okay, from alkene become diol. Okay, 2 alcohol, 2 OH group, we call it diol. So alkene become diol. And how is the OH added? Just add the next carbon, right? Okay, the OH is added across C double bond C. So over here, we should you should be able to recall the reactions by adding co-dilute acidified potassium permanganate 7. Potassium manganate 7, no per, sorry. The co-dilute acidified potassium manganate 7. Okay. Co-dilute acidified is actually the condition. Then the reagent here is actually the potassium manganate 7. Okay, you have all this, then 1 mark. Okay, co-dilute acidified, you must have all these 3. Okay, if you doesn't have all these 3, then this 1 mark basically you will lose it. Okay, then Roman 2 state and explain how 2,4-DMPH can be used to detect the presence of V. Okay, state and explain how 2,4-DMPH can be used. Okay, when you use something, the test, right? This one we call is reagent 2,4-DMPH. It is actually a test to detect the presence of the carbonyl. Okay, carbonyl. Okay, so it means C double bond O, aldehyde or ketone. Then what you need to write it down is actually the observation. Okay, observation. When you add 2,4-DMPH, if there is carbonyl, then what would you notice? Okay, all this you need to memorize. You can write orange precipitate or yellow precipitate. Both are accepted if not mistaken. But personally, I use orange lah. Okay. Orange precipitate. Yellow is also accepted. Yellow or orange precipitate is formed or is observed. Okay, 1 mark. Okay, why there is orange precipitate or Y24DMPH will detect the presence of V. Explain how. Okay, because the compound V has a carbonyl group. Carbonyl group, or you can write it is ketone, right? V. Yeah, V here. It is ketone. Okay, or you write it specifically. V has a ketone group. Also can. Okay, 1 mark, 1 mark. Okay, so 2 marks here. So actually this paper, right, they don't really ask much about the organic reactions. Okay, it's too bad. Okay, number 3. Progress of reaction 2 can be monitored by infrared spectroscopy. Okay, then the absorption caused by OH bond is always present. Okay, here. Okay, OH bond is always present because water is used as a solvent. Actually, this statement is okay. Let us look at the reaction 2 first. Okay, reaction 2 is from U to V, right? So from here, what we can notice is OH bond disappear, right? And C double bond O come out. So if we only base on the reactions, we should be able to write down the absorptions. The OH absorption should disappear from the infrared spectrum, right? This is what usually we do in the practice. But over here, they mention about the waters used as a solvent. So water is OH, H2O, that is OH bond. So your answer in this question, you cannot write down OH bond as the we say indicator. Okay, you cannot write down the OH bond as the indicator to be monitored. Cannot. Okay, yeah, because there is water inside. Yeah, then what is the another two? The first one, I believe most of you would say the carbonyl compound, right? The carbonyl group for the C double bond O. So you can write down. Okay, this is the what I want to say. This is the previous versions infrared data. Okay, I remember there is a slight difference compared to your current one, which I already modified in the notes. Okay, yeah. So this one is I refer to the old version. So the answer is 167 O to 1740. Okay, wave number. This is what we can absorb. This is what we can observe, the absorptions. Okay, then what is the bond responsible due to the C double bond O of carbonyl groups. Okay, yeah, this is, I believe most of you can notice this one. Then how about the another one? Okay, the another one, right? You can, the other thing, I don't think so. C double bond O, we already write it down. Then the another one is the C single bond O, which I usually don't recommend you to write it down unless you have no choice. For example, this question. Okay, they request 2 absorption, right? Okay, OH you cannot write it down as they already mentioned, there is water. Then C double bond O is one of the answer. How about another one? Another one is the C single bond O. Okay, C single bond O, if you have other alternative, then you don't write it down. Okay, yeah. But over here we have no choice, so it will be 1040 will become 1300 per centimeter due to C single bond O of alcohol. Okay, 2 marks. Okay, then the some reaction of V are shown. V to form W. Okay. Then, okay, reaction 3, actually it is Iodo form test, if you remember. Then reaction 4 basically is the reduction reaction. Okay, we use NaBH4, then dehydration. Okay, then addition polymerization. Okay, for the reaction 3. So, what would you observe in reaction 3? If there is positive result or positive observation. No answer. The question requests for an observation. Means visual observation. What would you see? What would you see? Okay, you will observe yellow precipitate, or you can write yellow solid. And the identity of this yellow precipitate, it is the trihydromethane, if you still remember CHI3. Okay, yeah. When we write something observations, always the color of the solid or color of the precipitate. Okay, reaction 3 is also a redox reaction. Identify which reactants is reduced. Okay. Yeah, this one it requires you to know your another product, which is CHI3. The I in the CHI3, it is -1 oxidation number, and here we have iodine. Iodine is element, so 0. So which reactant is reduced? Right, they ask which reactant is reduced from 0 to -1. It is iodine. Or you write down I2, also can, no problem. Okay, then construct an equation for reaction 4. Okay, for reaction 4, okay, they provide you the skeletal formula, right? Then what you need to write it down is, you need to count it, count how many carbon, hydrogen, and also oxygen. 1, 2, 3, 4, 5, 6. So initially it is C6H12O. This is provided from the questions. Then what is the product? Okay, product, if you count it carefully, same number of carbon, just the hydrogen. If we have 3 here, 3, 3, 3, 9, 9, another 3, 12, 12, 1 here, 13, 14. So 14O. Okay, so C6H14O. We will get C6H14O plus, no plus. Then since the oxygen is balanced, carbon is balanced, then we only need to use this atomic hydrogen to represent the hydrogens come from the NaBH4. So just 2 here, right? In order to balance the number of hydrogen. Yeah, that's all, very simple. Okay, then X is a mixture of 2 optical isomers. Draw 2 optical isomers in the boxes provided. Okay, we look at the X. Okay, since it is optical isomer, so you need to be able to identify which one is the chiral carbon, right? So this is the chiral carbon. Okay, this is the chiral carbon. Then what we need to show here is, okay, optical isomers always draw 3D. Always draw 3D. Okay. Then we always start from the chiral carbon, which is located at the center. Then OH, H, CH3, then C, CH3, 3. Okay, then we draw the mirror image carbon, OH at the top, hydrogen, CH3, then C, CH3, 3. Yeah. Okay, as long as you show it mirror image and all the, we say the groups, okay, they are correct. OH, HCH3, C, CH33. So there are 4 different groups of atoms. Then your optical isomer, they are correct. Okay, V. Both optical isomer X can be dehydrated to form a single product Y. Okay, what is Y? Let us look at it. Y is the alkene. Right. So from alcohol undergo dehydration. Dehydration, obviously, it is elimination reaction as well, right? Okay. Yeah. Elimination, dehydration from alcohol to become alkene. Okay. So, and reactions 5. Reaction 5, it requires, okay, no. Then what is the reagent and condition required for the reaction 5? Still remember? From alcohol to alkene. What is the reagent and condition required? There are quite a lot of answers accepted here. Okay, reagent is concentrated H2SO4, correct. Okay, heat at 128 degrees Celsius. Usually for this one, you can we can just write and heat and heat. This one no problem. Okay, 180. I'm not sure 180. If you write 180, I think no problem now. Okay, as they accept the heat as long as you mention heat, then it is correct for the condition part. Okay, yeah. Yeah, concentrated H2SO4 and heat. And you can use H3PO4 if not mistaken. I think one of the answer accepted by the marks team. But usually I will advise you to use H2SO4. Then another one is porcelain chips. Okay, porcelain chips and also be heated. You can also dehydrate the alcohol to become alkene. Yeah. Okay. Then the number 6, Roman 6, Y can form an additions polymer Z. Okay. For this one, usually I will advise you to draw the alkene. Okay. In another form means you make your C double bond C at the center. Okay, if you draw the C double bond C at the center, you should get something like this. C double bond C. Then you will have H, 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 C, CH3, 3. Okay, if you can get this form, then I believe when it comes to drawing the repeat unit, then you just need to open the C double bond C, right? So C single bond C, then H, 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 C, CH3, 3. Okay, just like this. One repeat unit, only one. Okay, follow the instructions, then you will get 1 mark here. Okay, then reaction 6. Reaction 6 does not proceed quickly at room temperature. Okay, suggest why this is the case. Okay, reaction 6, if you look at it, it is polymerizations. Okay, polymerization. Polymerization require high temperature, high pressure. Okay, this is what written in the notes. Okay, since usually it require high temperature. Okay, over here it says that it does not proceed or take place quickly at room temperature. Means why we need high temperature? Because there is high activation energy. Okay, yeah, so that's why that this is the case. The activation energy of reactions is high. Okay, 1 mark. Okay, so that will be the question for the paper 2. Okay, only 60 mark if you notice it, and throughout the questions only 3 questions. If not mistaken, this is the smallest number of questions come out. Okay, yeah. And I think for the organic part is quite easy. Yeah, organic part is quite easy, super easy, as they don't really ask a lot regarding the reaction. Yeah, but they ask a lot for the inorganic part, okay, which is another difficult topic for you. Okay, I think let us take a 5-minute break. Then later on we come back for the discussion for the paper one. I think you can have a look at the paper one first. If you have done it, then maybe we can discuss the question you would like me to discuss. Okay, 5 minutes. We come back by 10:25. Okay. Let's come to the paper 1. Did you try the question? Or I give you answer first? I Okay lah. I think I discussed in this way. For the easy question, I think I will just give it. Okay. For those which is difficult one, I think I will discuss it. Okay. Then for the question one basically is very simple. As long as you calculate the mole, then you will definitely find the simplest mole ratio, which is A. Okay, the answer it will be A. B. Okay, question 1. Question 2. Which statement is correct? Okay, this one you need to be careful with the terms they are using. So 1 gram of hydrogen gas. Hydrogen gas is H2. Okay. 1 gram of hydrogen gas. Okay, H2, the relative molecular mass, it should be 2. Mr should be equal to 2. So 1 divided by 2, you get 0.5 mole, which is you get 3.0 times 10 to the power 23. But it is not atom, it should be molecule. Okay, so A is wrong. B is, okay, B, helium. Helium is atom, right? Okay, helium. So helium, it should have, I think, helium usually the mass number is 4. Right, 4. Okay. So 4 divided by 4, you should get 6.0 times 10 to the power of 23 atoms. Okay, not so the value here is wrong. C, 16 gram of CH4 methane gas contains 3.0 times 10 to the power of 24 atoms. Okay, CH4 16 grams, so the MR also 16. So 16 divided by 16, you should get 1 mole lah. Okay, you should get 1 mole. But the value here, it is too big. Okay, if we want to have atoms, right? Atoms 1 mole. Okay, atom. So we will have 5 mole of atoms. So 6. Okay, yeah, 5 mole of atom. Okay, here 5 mole of atom because CH4, right? So 5 atoms. So 1 mole of methane gas will have 5 mole of atoms. So this 5 mole of atom, you multiply 6.0 0 times 10 to the power of 23, you will get 3.0 times 10 to the power of 24. So which is the correct answer? So C is the correct answer. D donkey 44 gram of CO2. CO2, the relative molecular mass is 44. So 44 divided by 44, you get 1 mole. So 1 mole of molecule. Okay, so here it should be molecule, not atom. Okay, number 3. Okay, number 3 is they give you this technetium, okay, TC. It is a second row of transitions element. Okay, for this question, right, you can refer to the data booklet, the periodic table. If you look at the periodic table, second transition element, right? Okay, TC is at the group 7. Okay, 1, 2, 3, 4, 5, period 5. Period 5, group 7. Okay, from here you will notice that they're asking about the nucleon number, right? So what is the proton number? Proton number, it is 43. Okay, 43 plus 56. What is the nucleon number? 99. Okay, this one quite easy. Okay, 9. Proton number for, yeah, 99. Okay, 99. Okay, then number 4, the answer is B-boy. Okay, number 4 B-boy. You need to draw the atomic diagram. Okay, then you can see for the nitrogen, it has 1 pair electron. Here you have 3 single unpaired electrons. So 3 to 2. There are more unpaired electron. Okay, more unpaired electron. Okay, number 5, the answer is non-linear. This one you can draw it by yourself. Number 6, which molecule has the largest overall dipole? Okay, this one I think A and D you were definitely out already, right? Okay, this is one of the practice in the notes I remember. Okay, so for this question, you need to be able to identify each individual dipole moment, means each bond, the bond polarity. Cl is more electronegative than the carbon, so it will pull in this way, pull in this way, pull in this way, the oxygen. So from here you can see, right, the arrow or the arrow, they are divert. Okay, they are not converging, they are diverging, means they are spreading out. Okay, so means every direction they are pulling to the pulling outwards from the carbon atoms. So as a result, right, so this one, it will result in a low overall dipole. Unlike the B, C, and H, right, if you compare with the dipole, it will be moving towards the carbon, pointing towards the carbon, and pointing towards the O. So they have one direction. Okay, so at the end, right, we will have a net dipole moment moving to the left. So the largest overall dipole moment, it will be B-boy. Okay, 7. Okay, for the question 7, boiling point, we always look at the number of electrons. So from here, it will be the donkey. Okay, this one you can look one by one. But as however, for example, the B, statement B, okay, never compare boiling point with the bond energy. Okay, never compare, never. Okay, this is the mistake usually made by the student. Okay, number 8A. Okay, this is the expressions. You can derive it by your own, I believe, no problem. Okay, number 9. Number 9, you need to be careful. Huh? Okay, number 9, you need to be careful as what we have here is about, okay, the equation provided to you is NH3 plus HCl to form NH4Cl. But means it is formation, right? Formation. Okay, but what is the diagram provided to you is decomposition, means the reverse of the reaction. Okay, so formation is exo, so the reverse it should be endo. Okay, so C and D, it will be the wrong answer. Okay, then A and B, they are showing endo, right? Okay, so endo is correct. Then let us look at the labeling, whether they are right or not. Okay, delta H, both are correct. Okay, EA, we are measuring from the reactant. Our reactant is NH4Cl, so the correct one is B boy. Okay, number 10. Number 10, this one you need to write down. Okay, the formula. Carbon monoxide is oxidized to carbon dioxide, CO to become CO2. So from positive 2 become positive 4. So the change is plus 2. Okay, the question over here, they are asking about the changes. So CO to CO2 is plus 2. Then for the nitrogen is NO become N2, right? Okay, so from positive 2 become 0. So the changes is negative 2. So the answer D donkey. Okay, then next 11. 11, NO and NO2, right? Both are present in the lower atmosphere as pollutant. Okay, then they give you the sequence of the reactions below. Okay, if you only look at the sequence, you will notice that it seems like, okay, it seems like what? It seems like only NO2 is reactants. Only NO2 is catalyst, right? Okay, if you look at the sequence only. So we will have NO2 is consumed and regenerate again. Okay, so if you look at this way, like step 1, then step 2. Okay, then is it possible for the NO react with the oxygen gas first, then become NO2, then NO2 become NO plus O. Means this is the step 1 and this is the step 2. Is it possible? Actually possible as well, right? If you look at the question, NO and NO2 are both present. Okay, in the air, in the atmosphere, NO and NO2, they are present. Okay, means none of them are intermediate. Okay, over here, okay, in this question, none of them are intermediate. They are reactants. At the same time, both of them, right? Both of them are actually behave or act as the catalyst. Okay, means NO react with the hydrogen gas, become NO2, then NO2 become NO and producing oxygen. Can, no problem. Okay, yeah, or the another way around. So which one, if we start from this one first, okay, the second equation as our step 1, so you will notice that this will consume, right? Consume, become NO2 and regenerate again. Okay, so it actually depends on how you look at it. So there are 2 ways for us to look at it. Then means both are catalysts. Okay, both are catalysts. Okay, 12. 12, the answer is C. Okay, you cannot write D donkey, yeah? You cannot write D donkey as SO3 and P4O10 both will result in strong acid. Okay, strong acid, yes, the pH definitely lower than 7. But what is the question? Question just want to have a pH of just below 7. Means it is just slightly acidic. Okay, A and B, I believe you are not selecting as your answer. Okay, the answer is C. Yeah? Okay, C. NaOH, if you dissolve in the water, we will get sodium oxide. If you dissolve in water, you will get sodium hydroxide. Then P4O10, you will get H3PO4, right? Okay, for the phosphoric acid, yeah, it is we say triprotic acid. It can release 3 hydrogen ion per molecule. Okay, 3H plus. Okay, 3H plus. But only the first H plus released by the H3PO4, it is strong acid. Means H2PO4 negative. Okay, this is considered weak acid. Okay, so the first acid, right, H plus react with the OH negative, it will already neutralize. So what we have at our mixture, or we say resulting solutions, we will only have the weak acid. Okay, we will only have the weak acids, which is just below 7, the pH. Comparing to the D donkey, D donkey both are strong acid after dissolved in the water. The pH value will very close to 1 or 2. Okay, then for the 7, maybe the pH is around 4 or 5 for the weak acid. Okay, so C, it is a better answer or more accurate answer. Okay, yeah, then 17 is straightforward question, so the answer is B boy. Okay, this one I'm not going to discuss it. Okay, 14, as long as you write down the equation, if you are able to write down the equations, then you should be able to look at it. Okay, carbonate decompose, it will release CO2 gas. However, nitrate, you will release 2 NO2 gas plus half O2 gas. Okay, now we look at the difference, the gases product. Carbonate only release CO2 and it is 1:1 ratio. Okay, so 0.005 mole will give us 100 centimeter cube of gas, and this gas is CO2 gas. Okay, and it is 1:1 ratio. Okay, then the gases product produced from the decomposition of calcium nitrate, it will be NO2 and oxygen gas, right? These two. And what is the ratio? 1 mole to 2.5 mole, right? So given the same number of moles, 0.005, it should give us 2.5 multiply 100. So we will get 250. So this is how we solve the question. Okay, 15 straightforward questions. Okay, the answer is A. 16. Okay, 16. Okay, this one. Okay, we look at K1 and K2 first. Okay, we look at K1 and K2 first. From here, right, if we compare K3, K1, K2, K3 definitely is the greatest one, the largest one, right? Okay, as they already told you, this one lies to the right, K1, K2 lies to the left. Okay, so lies to the right means there are more product. Okay, more product. So the value of the K3 is the largest. So A and B are. Okay, so C and D, basically here we are going to compare. Okay, we are going to compare K1 and K2, which is more so-called greater. Okay, then how are we going to look at it? Okay, we look at in this way. Here, this is the statement. Silver iodide will not dissolve in aqueous ammonia, but silver chloride will dissolve. So means that K2 multiply with K3, the value, okay, is greater than K1 multiply with K3. Okay, why multiply? Because we add the ammonia. Okay, we add ammonia goes into the silver chloride and the silver iodide, right? Okay, we will get the another new equilibrium. Okay, for the K2 is K2 is iodide. Sorry, I write wrongly. It should be smaller. K1. Okay, yeah, correct. So K1 is the AgCl one, right? AgCl. K2 is the AgI. Okay, so AgCl is greater than the Ki as AgCl can dissolve. So from here, right, since both are multiplied to the same constant K3, so means that the value for the K1, it should be somehow greater compared to the K2. Okay, so K1 is greater than the K2. K2 is the smallest, so the answer it will be C. Okay, so this is how we answer the question. Okay, 17 basically you need to remember the color lah. Okay, you need to remember the color. A metal that burns with the red flame is strontium. Okay, this one you need to memorize. Then why is an ion reacted with the H2SO4 to produce H2S? So this one, the only iodide, okay, only iodide ion can oxidize. Only iodide ion can reduce concentrated H2SO4 to produce H2S. So the answer is D, Gonki. Okay, 18 is A. Okay, this one straightforward and also it is in the notes already, so I won't explain here. Okay, 19 MgOH. Okay, this one Mg hydroxide, magnesium hydroxide, MgOH2. Okay, MgOH2 is base. Base dissolved in aqueous ammonia chloride. So ammonium chloride, actually we have ammonium. So ammonium is actually weak acid. So neutralization. So the answer is D, donkey. Okay, 20 basically you just count it lah. Okay, the answer is C. Okay, here I will make marking, okay, on the chiral carbon. Here 1, 2, 3, 4, 5, 6, 7. Yeah, 7. This 7. Okay. 21. Okay, in order to produce free radicals, okay, here radicals, the bond fission it has to be homolytic. Okay, then for the bromine is 35, the electron in the homolytic, in the free radical, bromine free radical 35. Okay, 22. Okay, this one, 1, 2, 3. Okay, 22 a little bit difficult. Okay, let us look in this way. Okay, 22. What you need to come out in your mind is it is alkene. Okay, as it can decolorize aqueous bromine, right? So why is alkene? Okay, then they provide the mass and the volume at room condition. So using these three information, right, you should be able to calculate the number of mole. Take 3.43 divided by 24, then you get mole, right, and your mass. So you take mass divided by mole, then your MR, relative molecular mass, you should get around 70. Okay, this one very important. You need to get the MR equal to 70, then only you can come out the molecular formula. Okay, then at the end from here, you should get the molecular formula is C5H10. Okay, C5H10. Okay, then you can only draw the structures based on this molecular formula. And remember, no rings. Okay, no rings. Okay, for these questions, let us move to the whiteboard. I will show you the okay, this one is 22, 22. Okay, since it is C5H10, okay, alkene, okay, contains no ring. So let us start from the straight change. Okay, usually for the isomerism, right, isomers, drawing the isomer, personally I will advise you from the straight change. It will be the straightforward one. Okay, the easiest one. 1, 2, 3, 4, 5. Okay, then where is the double bond? Okay, double bond, it can be here, right? Okay, can it form cis trans? C double terminal C double bond C cannot form cis trans. Okay, so only one structure. Okay, if you look at the question, right, over there they mentioned about structural and stereo isomerism should be taken into account. Means you need to consider cis trans isomerism. Okay, yeah. So for the terminal C double bond C, no cis trans. Okay, then what if one of the carbon now it become side change? So 1, 2, 3, 4 as the main change, then one carbon side change. Okay, this is another C5H10, right? Okay, also no cis trans. Okay, then the carbon can move one more, can move to the C double bond C, right? So we can have another structure like this. No cis trans. Okay, yeah. Then okay, then now we move the double bond to the second carbon. Then we will have C1, 2, 3, 5 double bond here. So if this is the case, then we will have cis trans, right? So cis trans we need to consider 2. Okay, here we have cis trans isomer. So 2. Then is there any possible branch can come out? Yes, right? So 1, 2, 3, 4, then double bond at the middle, carbon adding here. Okay, then you will notice that these two, they are identical CH3, so no cistrons. At the end, how many? 1, 2, 3, 4, 5, 6. So there are 6 isomeric structure, or means 6 isomer. That is without the ring one. Okay, yeah, so the answer is C. Okay, 23. Okay, 23 is the free radical substitution. For this kind of the questions, if you notice there is H radical, definitely wrong. H radical wrong, H radical wrong, because there is no H radicals exist in the whole free radical substitutions reaction. Okay, then D is eliminations. It is not propagations. So the answer is just A. Okay, 24 is stage 1 nucleophilic substitution, stage 2 is hydrolysis. So answer C, this one is quite straightforward. Okay, 25. Okay, 25. Let us look at this question. Okay, you see, they mentioned about the halogenoalkane does not form an alkene, does not, when treated with ethanolic NaOH. With the correct reagents and conditions, why the reactions cannot take place? Okay, this you should ask yourself in the question. Okay, with the correct reagent and conditions, why the reaction cannot take place? Okay, then this is what reactions? Halogenoalkane become alkene, right? So this is elimination. Okay, this is elimination. So how is the elimination take place? They will remove the halogen with the hydrogen at the adjacent carbon. Okay, at the adjacent carbon, hydrogen at the adjacent carbon. Then only when the halogen, okay, the carbon bonded to the halogen, right? Then the adjacent carbons does not have the hydrogen. Then only the eliminations cannot take place, even with the correct reagent and condition. Okay, so the region here, it should be no hydrogens at adjacent carbon. So you need to come out with the structure, then you know, then you look at it one by one. Then I showed you the correct answer, which should be the D donkey. Okay, if you draw it out, right, we will have 3 carbon, then C. Then where is your Br? Your Br is here, first carbon, right? Then you will notice that the only adjacent carbon is this. It doesn't have H. No H. So this is the reason the elimination reaction cannot take place. Okay, actually this is quite similar with the alcohol. Do you still remember why tertiary alcohol cannot undergo oxidation? Similar. It doesn't have H. Okay, that's why it cannot oxidize. Yeah. Okay, 26. Compound P is heated under reflux with an excess acidified potassium dichromate 6 to form Q. Okay, so heated under reflux with acidified potassium dichromate 6. So this is oxidation. Right, so oxidation. Okay, so one primary alcohol, butane 1O is primary alcohol. So it will oxidize, become carboxylic acid. Okay, then 2-methyl-butane 2O 2,2. So this is tertiary alcohol, cannot oxidize. Pentan 1O is primary alcohol. It will oxidize, become carboxylic acid. Pentane 2O will oxidize, become ketone. Okay, compound Q, which is the product, has a lower boiling point than compound P. What could be the compound P? Okay, carboxylic acid, they can form stronger. Cannot say stronger lah. They can form more hydrogen bond per molecule compared to the alcohol. That is the reason why carboxylic acid, the boiling point is greater. Okay, so A and C out. Then B, there is no product, no compound Q, cannot oxidize. So out. The answer, ketone. Ketone cannot form hydrogen bonding. That's why the boiling point is slightly lower. Okay. Okay, 27. Okay, again, elimination. And you need to consider structural and stereoisomerism. Okay, this answer is A. Okay. A, right, after you remove the H with the H2O, let's say the double bond forming here lah. Okay, and we have cis trans. Okay, cis trans. So one cis, one trans, two product. Only two. Okay, so the answer A. Then B different. B, the double bond right after is removed, it can form at the left. Then this we will have two cis trans. We have two products because cis trans, due to cis trans. Then another possible we form here at the terminal. So plus another one. 2 plus 1, we will have 3 products for the B boy. Then we can form the double bond here. Okay, here no cis trans. Then plus another one, it will be here. Okay, the double bond here, it can form cis trans, the green one. So 2 plus 1, also 3 product. Okay, D donkey, the OH will remove here. And 1, 2, 3 here. Okay. Then we will have 1, 2, 3. Okay. Then we can have okay, 1 cis, 1 trans for this double bond. So times 2. Okay, 1 cis, 1 trans. Okay. Then another option is if because 2 OH, right? So if there is one double bond forming here, then it can be the OH removed, this OH, or sometimes this OH. Okay, so over here another 2 product already. Okay, so we already have 2 and initially 2, right? Cis trans, then another 2 here. So total we have 4, if not mistaken. Okay, 1, 2, 3, 4. Oh, one more. One more is like this. Okay, forming here, then this forming here. 1, 2, 3. No. This is the previous one. Yeah. So only 4. Okay, for this only 4. So 2, 3, 3, 4. So the answer is A. Only 2 organic product are 4. Okay, 28. Okay, react with 2,4-DMPH. It must be carbonyl, right? So carbonyl, it can be aldehyde or ketone. So A out. A is alcohol. Then the one that also can react with alkaline aqueous iodine, this is Iodo form test. Okay, so Iodo form test for the carbonyl compound, it should have C double bond O CH3 structure. Okay, it must have this structure. then only it can give positive result. Aldehyde cedar bond O is terminal one, which doesn't have this structure, so aldehyde up. Then then you draw C and D. Butanol is 4 carbon, right? 4 carbon. Then we have double bond O, CH3. You have this structure on the butanol, so C is your answer. Pentane trione, no. Okay, 1, 2, 3, 4, 5. Double bond O here. You doesn't have CH3 group. You have CH2, CH3. So it cannot give positive result for the alkaline aqueous iodine. Okay, yeah. Then 29. Okay, another complicated question. Okay, 29, you need to be careful as they mention about organic compound Z has an alcohol and a carboxylic acid group. Then they react with what? With carbonate. Then first thing first, you need to ask yourself, it is magnesium. Okay, it is magnesium. And what is the functional group that can react with the carbonate? Alcohol or carboxylic acid? Alcohol cannot react with the carbonate. So the reaction here is carboxylic acid react with the carbonate. So what you have here is, don't forget that your carboxylic acid, let's say it is how I put it? Okay, let's say I put the carboxylic acid as HR. Okay, R is the hydrocarbon part. Okay, then hydrocarbon part react with the carboxylic acid react with magnesium carbonate. What is the salt? The salt you get, right, is Mg bracket R2. This, the formula, this is the key point. Okay, this is the key point. Means you need the salt here, right? The salt, the relative formula mass is in this form. 1 magnesium 2 plus ion and another 2 carboxylate ion. Okay, 1 magnesium 2 plus and 2 carboxylate ion. So what the relative formula mass here provided to you, right? You need to, you take 230.3, you minus 24.3. 24.3 is the magnesium, the relative atomic mass. Then what you get is 206. Then this 206 you need to divide it by 2. So only we get this one, 103. 103 is the carboxylate ion with the negative charge, then plus 1 hydrogen. So your compound Z, right, the relative molecular mass should be 104. Okay, yeah, this is the complicated part that you need to be able to notice. Okay, yeah. Then another information provided here is compound Z does not react with the acidified potassium manganate 7. Means the alcohol is tertiary alcohol. Okay, tertiary alcohol. So from here, if I look at it, right, the number, right, you can see 2222322, right? 3232 means the OH is not at the with the is at third carbon, then 2 is the side change at 2 carbon. These 2, right, they are secondary alcohol. Okay, so if you draw it out, you will notice one is secondary alcohol. So it's not our answer. Our answer, it have to be tertiary alcohol, right? So it should be 2222. Then another thing that you need to find out is this 104. So you can go and calculate lah. Okay, the answer is B boy actually. Then let us draw it out. So we will have CH3, CH3, OH, then COOH. Okay, we will have 1, 2, 3, 3 carbon. So 36. Sorry, 4 carbon, 48. 48, 1, 2, 3, 3 oxygen. Yes, this is about. Okay. Then how many oxygen? 3, 3, 1, 8, 6, 8. Okay. So 96 plus 8, we get 104, which is matched with the what we have calculated just now. Okay, so the answer is B boy, not A. Okay, yeah. 29 is another complicated question. Okay, 30, 30. Okay, 30. For this, right, what you need to notice here is this is the OH peak, right? I believe you should know lah. Okay, OH peak, but which one? Carboxylic or alcohol? It should be the alcohol one, as it close to the 3500 already. Okay, it is considered quite close to the 3500. If it is carboxylic acid OH peak, it would be around 3000. Okay. Okay, so from here, let us look at our answer. Is there any alcohol? The A, no. A is external alcohol. B, yes, we have alcohol. C is carboxylic acid, so out. D, donkey, we have alcohol here. So B or D, lor. Okay, then is there any C double bond O? This is aldehyde, right? This is aldehyde. Okay, so from 1,6 something to 1,8 something, there is no strong absorption. So no C double bond O. So no aldehyde. So the answer is B boy. Okay, 30 is considered quite easy. Okay, then 31. For this type of the questions, you are not going to encounter in your coming exam already. Okay, however, I plan to discuss with you guys. Okay, yeah. Okay, 31. Which statement correctly describe the features of this diagram? Okay, the first one is correct. Okay, T1 is lower than the T2. The shaded area indicate the particle have sufficient energy to react at T2. The shaded area, yes, shaded area is at T2. Yes, correct. Then number 3. Number 3, they mentioned about the total area under each curve is same for both temperature. Yes. They are mentioning total area, not total shaded area. Okay, means this is the total area for the T1. Okay, then T2 I use the yellow color to represent. This is the total area for the T2. These two areas, right, they should be the same. Okay, yeah, so the answer is A. Yeah, I think statement 1 and 2 you should have no problem lah. Number 3 a little bit, you need to be careful, okay? As statement 2 it mentioned about shaded area, right? Then sometimes statement 3 your mind will automatically treat the total area under the curve is shaded under the curve. Okay, that is the thing that you need to be careful. Okay, 32. Okay, it is about acid and base. Acid 2 has a lower pH than acid 1 because it is more soluble. Okay, the statement is correct. Acid 2 has a lower pH than acid 1, but wrong reason. Because it is more soluble. No. Because acid 2 can dissociate completely. Okay, that is the reason it has a low pH. So statement 1 is wrong. B has higher concentration of the hydroxide ion. Yes, correct. Acid 1 dissociate less compared to the acid 2. Yes, correct. So this is C. 2 and 3 correct. C. Redox reaction, this one should be easy. You can look at it by yourself. Only one is correct. So answer is D donkey. Okay, 34. 34, you need to okay, this one you need to know what is the structure first for the N2F4. N2F4 is very rare in the discussions or in any practice. However, it has the same structure for the N2H4. Okay, so actually the structure for the N2F4 is something like that. N single bond N, then we have 2F here. We have 2F here. Then lone pair, lone pair. It decomposes into a single product. Okay, single product, how it is going to break the bond, or how does it going to decompose to only have single product? Decompose symmetrically here. Okay, so N2F4 we will get 2 and F2. Okay, this is how it is composed. So which statements are correct? NF bonds are broken during this decomposition. Does it correct? No. The only bond broken, right? Only N single bond N broken. NF bond is not going to broken. Okay, so the statement 1 wrong. Okay, number 2, enthalpy change when N2F4 decompose into X is approximately positive 196 kilojoule per mole. Okay, how are we going to know this? Okay, if you refer to the data booklet, okay, for the bond energy part, if you look at the N single bond N, okay, the energy given to you is 190. Okay, so this is actually the bond energy for the N single bond N. So statement 2 is correct. Okay, then molecule X, NF2, the structure is basically like this. NF, then we have one lone pair and one unpaired electron. So this structure is non-linear, correct. So answer is C. Okay, 35, SiCl4 and SiO2. SiCl4 is simple covalent compound. SiO2 is giant covalent compound. How can a simple covalent compound, the melting point is greater than the giant covalent compound? So statement 1 is wrong. Okay, SiCl4 reacts with water. Yes, SiCl4, when you add water, goes in hydrolysis take place. You add NaCl into water, only dissolve. No reaction. Okay, only physical change, no reaction. So number 2 is correct. Then number 3, the melting point of SiCl4 is lower than the melting point of NaCl. Yes, this is simple covalent, right? NaCl is ionic. So yeah, number 2 is correct as well. So this is C. 2 and 3 correct. Okay, last page. Which statement about ammonium chloride are correct? It reacts with hot aqueous NaOH to produce an alkaline gas. Yes, NH3. This is NH3, yeah, NH3. So yes. In solutions, it reacts with aqueous silver nitrate to form white precipitate. Yes, AgCl. Okay, when it is solid, it reacts with the concentrated H2SO4 to produce chlorine. No. Okay, actually the statement number 3, right? They are test your knowledge on the halide ion. Okay, here the halide is chloride, right? Cl negative. So only Br negative, bromide can react with concentrated sulfuric acid to produce bromine? Yes, can. Or iodide. Iodide produce iodine. Okay, but chloride react with concentrated sulfuric acid. Sulfuric acid, it is not strong enough to so-called oxidize chlorine. Okay, so number 3 is wrong. Answer is B. What is the same for a pair of optical isomer? Optical isomer, they only difference in arrangement of atom. Okay, the only difference is arrangement of atom. So empirical formula same, functional group same, structural formula same. So this is A. Okay, which of the molecular represent at least one compound that can undergo additional polymerization? Okay, for this question, what you need to know is additional polymerizations can be only alkene to undergo. Okay, so you try to draw, can it form alkene? Yeah, C4H8, I believe no problem. C double bond C, then like this. Okay, at least one, right? So as long as you prove that is one, then this is the correct answer already. Okay, C2H6, C2H3Cl, C double bond C, then we have one Cl here. Okay, H, that is alkene, so they can form polymer. Okay, then how about C3H6O? Okay, C3H6O also can 3 carbon. Then let's say, okay, I show it in this way. C double bond C, then let's say here CH3. Okay, up here, let's say H. Okay, here I write CH2OH lah. Okay, CH2OH. So 3 carbons, 1, 2, 3, 6H, 1O. So that is alkene as well. Okay, so 3 also can. So A is the correct answer. Okay, 39. 39, you need to draw the product come out. Okay, number 1. Okay, HCN, it will react with the carbonyl part here, C double bond O. Okay, so what do we have here is the final product, it will be CH2OH, then C bonded to the CN, OH, then CO2H. 4 different group of atom, right? Okay, 1, 2, 3, 4. Totally 4 different groups. So A is our answer. Okay, B. NABH4, it can only reduce the carbonyl, the ketone. Okay, yeah. So I think, okay, I show the answer below as the space up here is limited. So for the number 2, we will have CH2OH, then carbonyl reduce, become OH, CH, then CO2H. Again, you can check 1, 2, 3, 4, 4 different groups. Okay, 4 different groups. So yes, there is chiral center. Okay, that is chiral center. 2 is correct. Okay, how about 3? Lithium aluminum hydride, it will reduce carboxylic acid. Okay, COOH become primary alcohol. Carbonyl, the ketone, becomes secondary alcohol. So number 3, right? Okay, number 3, the product, it will be CH2OH, CH2OH, Then we will H and also OH here. Okay, over here you will notice that left and right, they are identical, right? They are identical. So this is not chiral center. Okay, so only 1 and 2 is our answer. So the answer is B boy. Okay, then the last one, 40. Italbutanoid, this is ester. This is ester. Okay, is heated with a dilute aqueous solution of NaOH. So this is alkaline hydrolysis. Which substance are the product? Okay, then you need to recall back. The ethyl part is from the alcohol. Butanoid part is from the carboxylic acid, right? Okay, so usually ester is formed back, it will form back alcohol and carboxylic ester, but over here it is alkaline state. So alkaline state, the carboxylic acid, it will become carboxylate ion. Okay, then butanoid become butanoic acid. Then the ion, since here is sodium, right? So it will become sodium butanoid. So the number 1 is correct. Then how about water? Water, it is not product, okay? Water is reactants. If you write down the equation, you will notice it. It is reactants. Then there is no sodium ethanoate as alcohol. It is not going react with the base. So only 1 is correct. The answer is D, donkey. Okay. So we finished paper 1 and paper 2 in 3 hours 30 minutes. Okay, let me stop the recording.